Hi everyone, I'm Yoonjoo from KAIST. Today I'm presenting our work, PaperWeaver, Enriching Topical Paper Alerts by Contextualizing Recommended Papers with User-collected Papers. This work was done during my internship in Semantic Scholar at LNAI Institute. It was done with Hyeonsu, Matt, Juho, Jonathan, Joseph, and my internship mentor, Pao. With the recent proliferation of published materials, researchers face an even bigger challenge of keeping up with the literature. In order to accumulate this ever-increasing knowledge in a meaningful way, scholars need to both discover new and relevant papers and contextualize them to their research interests by making meaningful connections to their existing knowledge of the literature. Recently, one popular approach to help scholars discover relevant papers and make sense of them in their own research context has been to leverage paper recommender systems such as Archivist, ArchiveSanity, or Google Scholar. Researchers subscribe to paper recommendation alerts that include potentially useful papers to readers. Typically, these systems allow users to create paper alerts by providing a short description of a specific research topic and a set of sit papers as example of papers that interest them. However, current systems typically only show a list of titles and TLDRs for the recommended papers without additional descriptions relevant to the topic or theme of the folder they were based on. Therefore, researchers have challenges in sense-making about how this paper is relevant to them, and they can overlook important recommendations. Therefore, we started from this question, how to enrich paper alerts by contextualizing recommended papers with user-collected papers. Initially, to understand researchers' challenges with current paper alerts and identify key information needs to inform PaperWeaver's design, we performed a formative study with researchers in HCI and NLP using multiple design probes. We asked participants' experience with current paper alert systems by showing them recommended papers and the standard alert systems by showing a list of titles and abstracts. We also conducted a think aloud interview by walking them through a set of design mockups. Our formative study revealed that the main challenge lies in determining the relevance of recommended papers by just reading their titles, or briefly skimming the abstracts. Reading the full abstract or part of the papers could help decisions, but costly, people often resort to inefficient strategies like keyword spotting, which leads to potentially overlooking important research. From the comparisons between mockups we provided, participants prefer contextualized summaries that surfaced information relevant to the folder content over a contextualized summary like TLDR. It's because contextualized one helps them effectively understand the relevance, while the other often omitted parts of the abstract that were relevant to the folder. Participants also expressed the need for descriptions focusing on comparing recommended papers with their existing collection, since it helped them recognize new papers that directly build on a paper they had collected, which is a main goal of sense-making a new paper. Our study also revealed that showing the comparison between new and existing papers leads to a rediscovery of the relevance and potential new perspectives of their previously saved but not thoroughly examined papers. To help researchers more deeply understand the relevance of recommended papers to their own research context, we proposed PaperWeaver, a new paper alert system that can enrich existing paper recommender systems by generating descriptions of how each recommended paper relates to a user's interest and their collection of papers. This is how our system works. Sophia started working on the topic of reading supporting interface a few weeks ago. She has collected a list of papers related to this topic in a folder. Her familiarity with each paper in the folder varies. She has read some of the papers, and for some other papers she only saved them because she saw a relevant keyword in the title of the paper but didn't have the time to read them yet. Because this is her active project, she is looking out for new papers relevant to the topic. She starts using PaperWeaver to more effectively process her paper alerts. With the folder title Reading Supporting Interfaces and the list of papers she has collected, PaperWeaver automatically expanded on the folder title to provide an overview summary of the source papers she collected. She also can modify the keyword like moving medical literature and adding LLMs to better reflect her research interest. After setting up the folder, while going through the recommended papers, She can immediately save papers with obvious relevance, like the Semantic Reader project augmenting scholarly documents through AI-powered interactive reading interface based on the provided title and metadata, like authors or TLDR. For the others, she explores the contextualized descriptions of the paper. She can open the Problem, Method, and Findings tab to see a summary of the paper by folder context broken down into the problem, method, and findings. With this information, she felt curious about Synergy paper. Then she can click Relate to Paper tab to compare the recommended paper with a paper site read that she is already familiar with. She learns how these two systems differently design interaction and notes interactivity to trigger user engagement as one dimension to design for the reading interfaces. She also sees that there is description for the Synergy paper and the paper she has collected in passing. By reading the description, she now recalls that Scheme supports paper reading by automatically highlight important content in a paper, and unlike Synergy, there is no personalization component in the system. After reading these descriptions, she is curious about what kind of design implications coming from Synergy. She went into the whole paper link. To generate contextualized descriptions like those in the scenario, we developed an LLM-based pipeline that processes the user's folder information and the recommended paper's content to generate descriptions for each recommended papers. As seen in the user scenario, PaperWeaver generates three types of descriptions. First, contextualized aspect-based paper summaries, and second, paper-paper descriptions based on sentences, and third, paper-paper descriptions via generated pseudo-sentences. First, to ensure that all these descriptions are relevant to the topic of the folder, PaperWeaver allows users to provide and update a succinct topic descriptions for their folders. To lower the effort of writing them, our system uses an LLM to generate a default description based on previously collected papers in the folder. Using this folder description, we extract the aspects that user who has curated this library folder might find relevant. There can be various aspects within the recommended paper. With this method, we surface more relevant aspects to this user. As types of these aspects, we use problems, methods, and findings, which are typically the main pillars of most papers. These describe research in a specific and comprehensive way at the same time. PaperWeaver also provided paper-paper descriptions that shows relationships between recommended paper and user-collected paper. When recommended papers cite one or more collected papers, we leverage sentences, which are citation sentences that link recommended papers to those in a user collection, serving as indicators of their relationship. We extract a full paragraph containing the sentence for broader context and employ LLM to create concise but comprehensive summaries, intertwining the essence of the recommended paper with its connection to collected works. However, this method does not apply to all recommended papers since some relevant papers can be omitted from the sentences. When direct citations are lacking, we employ a novel technique to generate pseudo-sentences. To find the relationship between papers, we use comparison, which provide concise descriptions of the most salient similarities along either the problem or the method aspect, and contrast, which surface differences along a different aspect. As an example, both Synergy and Scheme paper address the same research problem, managing and synthesizing information, but use different methods. Specifically, our method performs the following steps. Using the extracted folder description-based aspects, PaperWeaver finds relevant papers from the folder, then identifies shared aspects between each pair of the recommended paper and the collected papers to find similarities and differences. To ensure that shared aspect aligns with both papers, we proceed verification steps, and upon confirmation, we generate a structured summary. This dual method ensures a comprehensive and meaningful exploration of academic literature tailored to individual user contexts. To evaluate PaperWeaver, we conducted a within-subject study with researchers who were interested in receiving paper recommendation alerts. We compared PaperWeaver with a baseline similar to existing paper alert systems, but additionally enriched it with uncontextualized summaries and extracted related work sections from the recommended papers. Participants read paper alert, did the postdoc survey, and wrote a list of what they learned from the given paper alert, and these steps were repeated for the second condition. We investigated whether PaperWeaver can help readers efficiently understand the relevance of new papers, to triage them, and to deeply understand the relationship between new and user-collected papers and new aspects of the collected papers. Based on the post-hoc survey, participants felt that they could understand how the recommended papers were relevant to their own research interest significantly better in PaperWeaver than the baseline. We also found evidence that PaperWeaver supported decision-making. Specifically, participants felt PaperWeaver helped them decide which papers were worth saving and were significantly more confident in their decisions. We also found that when using PaperWeaver, participants on average captured significantly more notes than described connections between papers. Also in the survey, participants felt PaperWeaver helped learning something new about the papers that users have already saved. Although the positive learning effect could require significantly higher cognitive demands on the users, based on our NASA TLX survey, participants did not report a higher workload when comparing using PaperWeaver and the baseline. On the other hand, qualitative data shows evidence of higher mental and temporal demand for some participants when using PaperWeaver. Our observation shows that participants did a quick pass to filter out few recommended papers that seemed irrelevant. During the quick pass, participants mentioned that contextualized aspect summaries were helpful, since those surface aspects participants should focus on compared to TLDR summaries and explained papers in a more comprehensive way. Once quick pass is done, participants also relied on paper description. They mentioned that they can better understand how this paper is different from the paper that they've already known, and what new contributions are there in the recommended papers that were relevant to the collected papers. Interestingly, after reading the paper description, participants often still continued to examine the abstracts. Participants mentioned the goal was to both verify the LLM-generated paper description with the original sources and to gain deeper context around the paper description once they became interested in a recommended paper. LLMs sometimes produce inaccuracies, and our manual evaluation noted occasional errors in the generated descriptions. Aspect-based descriptions being more extractive showed fewer errors compared to the more inference-heavy relationship-based ones. In our user study, participants viewed these errors as acceptable. They are accustomed to verifying machine-generated recommendations, and they viewed PaperWeaver's descriptions as helpful supplementary material for paper triage without feeling an increase in workload despite the need for verification. In summary, PaperWeaver supported understanding of paper relevance and more effective relevance judgments and promoted discovery of more connections between papers. Our system also helped users to rediscover new information about the papers that they have already saved. There are many interesting discussion points. First, contextualized description has broader applications beyond the paper alerts. For example, it can aid collaboration by using an author's publication to generate descriptions for exploring shared interests with other researchers. Additionally, it can enrich the reading experience of related work sections by offering alternative descriptions based on familiar papers, and assist authors in framing their drafts by comparing with relevant new papers for insightful perspectives. Schema to compare multiple papers can be tailored for each user's need beyond the default problem method findings to accommodate individual research interests and deeper analytical needs. Actually, our study participants expressed a desire to customize the schema more finely. For example, they suggested preferences for specific aspects like evaluation methods, AI model development approach, and system interaction features. This customization could evolve dynamically, adapting to users' engagement patterns and providing more granular insights as they desired. Allowing users to update user context elements like folder description based on insights from alerts, or express their preferences for descriptions could lead to more customized and personalized future alerts for each user. The approach has the potential to transform folders into dynamic repositories of a user's evolving research knowledge. Additionally, the effective continuous updates on the user engagement presents an intriguing area for future research. For more information, please go check our paper. Thank you.